Okay, here is the last part of the worksheet for fundamental theorem of algebra and other polynomial topics, parts C and D. C says find all the zeros of this polynomial given that x equals to 4 is a zero of m of x. So we know that 4 is a zero. We've already practiced in parts A and B how we can begin to factor this guy. So let's run this through an iteration of synthetic division and see what happens. So let's go here. Let's say, put your C value here, draw your big long L. Coefficients up top, 1, negative 4, 5, negative 20. Oops, negative 20. Bring down your first number. 1 times 4 is 4. 4 minus 4 is 0. 0 times 4 is 0. 5 plus 0 is 5. 5 times 4 is 20. Negative 20 plus 20 is 0. All right, so m of x can begin to be factored into the given 0. We back it into factored form, x minus 4, times, this is the remainder. This is the constant term, the first degree, the second degree. 1 times x squared plus 5 is what this can be factored into. Now, this is not difference of squares because there's a plus there. That does not factor. So we'd have to solve this part for its 0. So let's see. X squared plus 5 is equal to 0. Let's solve this. Let's subtract 5 from both sides. Let's take the square root of both sides. X is equal to plus or minus the square root of negative 5. When you have a negative under a square root, that produces an imaginary number I. So x is plus or minus I times the square root of 5. And so just like we were talking about before, complex roots come in conjugate pairs, also radical roots. This one happened to be conjugate and radical, complex and radical. So it said find all the zeros. This is not a real root, this is an imaginary root, so we get x is 4, x is I times the square root of 5, x is negative I times the square root of 5. We found them all. All right, let's look at part D. D says, use the rational zero theorem to list all the possible rational zeros for the given polynomials. So that means we have to know what the rational zero theorem says. So let's look at the top of the worksheet where it talks about the rational zeros theorem. And so it gives you this polynomial. I'm going to write this down. It's the generic form. P of x is equal to a sub n x to the n plus a sub n minus 1 times x to the n minus 1 plus some more terms plus a sub 2 x squared plus a sub 1 x to the 1 plus a sub 0 x to the 0. We could write that on there if we wanted to. This is the big generic polynomial. What makes it a polynomial is the coefficients. All of the a terms are real numbers. They don't have to be whole numbers. They just can't have an I in them. And the degrees of the x's, the powers, they have to be whole numbers, positive whole numbers, or 0. But they can't be negative. So that's what makes that a polynomial. Now the rational zeros theorem is used to help us try to find where some possible zeros are. Rational means fractional. And so this is what it says. You can produce a list of possible zeros. And so the list of possible zeros would be you take plus or minus the factors of the last term, a sub 0, divided by the factors of the leading coefficient, a sub n. And so you can make a big list. So what we're asked to do in part D is to make the list. We don't have to find the zeros, we just have to make the list. And so the reason this theorem exists and why it was handy is before we had graphing calculators, we had to go find the roots by another method. And so one of the ways you could do it is choose this list, and that partnered with synthetic division was a really kind of a quick way to run through, and if your remainder was 0, you knew you found one, and if your remainder was not 0, move on to the next one. And so sometimes I've taught this class where I had students do that. I'm just going to have you make a list. So let's do part D. If we've got A, P of x is equal to x cubed minus 2x squared minus 13x minus 10. Then the possible the possible, it doesn't mean they're all zeros, of course, just these are the possibilities. The possible rational zeros is equal to plus or minus the factors of negative 10 divided by the factors of 1. All right, so what are the factors of 10 or negative 10, either one? 1 times 10, 2 times 5, and I think that's all the factors. What are the factors of 1? Just 1. Those are the factors. This is not a list, this is me getting ready to make my list. Okay, so here's the list. 1 divided by 1, negative 1 divided by 1, 2 divided by 1, negative 2 divided by 1, 5 divided by 1, negative 5 divided by 1, 10 divided by 1, negative 10 divided by 1. These are the possible zeros I could try. These are not that bad. I could run this through synthetic division and find at least one off of this list, most likely. Probably more than one. Okay, let's just make the list for part B. A little more room on the board. By the rational zero theorem, just make a list of the possible rational zeros for this polynomial. So, part B, if p of x is equal to x to the fourth plus 3x to the third minus 7x squared plus 9x minus 30. All right, so plus or minus the factors of the constant term, negative 30 or 30, either way you want to think of that, over the factors of 1. So that's nice that they gave us a 1. If they give you something like a 12, then there's a lot more combinations you'd have. So this is not too painful. What are the factors of 30? 1 times 30. 2 times 15, right? 3 times 10. 4 won't go into 30. 5 will. 5 times 6. These are all the factors of 30. What are the factors of 1? 1 and 1. And so we can make a list. It is okay with me, since I wanted to show you how you officially list it, if you just put a plus or minus in front of this whole list and say 1, 2, 3, 5, 6, 10, 15, and 30. That is what the rational zeros theorem says.